Hello and welcome to number 4 of the Open Source Silicon stream. I'm your host, Matt Venn, and welcome. If you've not been here before, then this is a bit of an experimental thing I'm trying. Just sharing some news and trying out some different experiments, like we've been looking at testing some previous designs. And usually I have a couple of topics prepared. So today we're going to have a look at some news to start with, and then the main focus is going to be trying to build a voltage controllable digital block. So I'll get more into that. It's quite an interesting question. So just a few bits of news. We had the Bring Up party, the Tiny Tapeout 6 Bring Up party last week, and that was great fun. We had about, I think, maybe 30 people join, and 10 or 12 designs were showed off, and we recorded that. I did a light edit, and that's available on the channel if you're interested to see. I put thumbnail timestamps in there so you can jump to the bit that you're interested in. Little bit of Tiny Tapeout in the news. Let me just present my screen here. So LinkedIn and Blue Sky are the places that mostly sharing Tiny Tapeout stuff. Think. There's a couple of posts I wanted to share here. And of course, I can't find them now. This is one from Franz. So this is a time interpolated NAND gate, time multiplex NAND gate, a single gate with an 880-bit shift register, fun experiment, and he's built that with Spade. So if you're interested in looking at a different type of hardware description language, you could check that out, and it's great to see that design working. Hi, Rohan. Hi, Sam. Welcome to the stream. Yeah, if you're watching, just drop your name and where you're watching from. It's cool to see people. We've also got an event coming up in Copenhagen. Can I find it? No. I should be able to find it here, though. Denmark. Yes, hi Thomas. Yeah, good to it'd be good to see you there. So if you're in the area, it's very close to I didn't realize actually so close to Sweden. So if you're in Malmo as well, feel free to join. And yeah, we're going to be running this in collaboration with Denmark Technical University, and with thanks to sponsorship from Danish Chips, Edu4Chips, Synopsys, and Silosil. So thanks everyone for helping with the sponsorship there. Hi Hanok. Hi from the Bay Area. Who hacked what? Hi Andy. Good to see you here, Andy. And what else do we have in the news topic? Oh yeah, the other event coming up is Hackaday Berlin 2025. There's still some tickets left for that if you want to join. They're going fast. It's always a good event. I'll be there. We're going to be running a Tiny Tapeout workshop there as well. And Uri has put the gamepad into the VGA playground now. So for the demo scene competition, which is open at the moment, one of the new areas of the competition, one of the new categories is a game. So it says TBD standardized on the controller, and Pat and Uri have been working on that in tech specs. Now we've got pinouts, and at the bottom we have the new game controller P mod, and then Uri's done a little experiment here where is it? Oh yeah, gamepad. Here we go. By pressing the buttons, so it's like the Verilog that you need here. And he recently just taped that out as well. I think if we go to Tiny Tapeout 10, yeah, and it the gamepad and the VGA driver. This demo basically taped out is 27% of one tile, so you can still do quite a lot of interesting stuff. So if you want to have a nicer interface, like a game controller interface, and try that P mod, and if you want to take part in the demo scene competition and enter the game category, then we've got you covered with the gamepad P mod. So I think that is it on the news side. Hi, Armilo. Hello from Northern California. So onto the main part of today's stream. So we had an interesting question coming through the 0 to ASIC course from someone who wants to see what happens as they lower the supply voltage of a digital design. And you might think that that's easy to do. You can just turn down the supply voltage, V core, and that would work. But that doesn't work because your design isn't the only design inside Tiny Tapeout. Your design is one of many designs. So if we just take one of these, we want to make it so that when your design is activated, it's as if it's the only design, but we can't get rid of the fact that everything is going through these muxes and everything is powered through power gating. So we try to make it as the simplest and the fastest logic possible, but that doesn't, we can't get rid of the stuff in between. And if you did want to get rid of it, you would have to jump up to something like chip ignite and take the full area of the chip yourself, which it's quite a cost jump. It's $10,000 for 100 chips, but you get a lot of area and you get those 100 chips. So what we were thinking of doing was, instead of trying to control V-core, because as you drop V-core, that's going to also drop the voltage of all your multiplexers. If instead we have a digital design, but we put it in one of the analog blocks, then we can power the design through the analog supply, because we have a separate 3-volt analog supply. So to show you that, I'm going to load up the demo board. So here's the chip, and down around we've got VDD-IO. So that's the IO voltage, so that drives the IO cells on the pad frame. The V-core is that's the 1.8 volts that drives all the logic, and then we have VDDA, and that's a separate power supply that we just use for analog designs. So the idea is, because we to basic, and that's also got a very convenient 0 ohm resistor placed here. Can actually see it. Maybe if I just remove this temporarily. On the top of the demo board, those 2 big resistors on the top there, they've got a 0 ohm resistor placed there. So you can remove that. That's it here, R3 and R4. And then you can supply your own VDDA. Just wondering if I can download, maybe I'm going to download Tiny Tapeout 10. I'll leave this open for now. Or maybe I'll go 9. GitHub repo, releases, download the Oasis file. I should be able to open that with K-Layout. Hi, NS. NS is asking if we can get dyes to look under the microscope. So we are currently working with Texplained, and they do our imaging for us. So we send them 2 dyes, they decap them, they do the imaging, and then we share the imaging with you. But you don't get any bare dyes. We don't get bare dyes. We have to get them decapped, which is also another reason why we're working with Texplained. You can order a chip and then try and decap it yourself, but it's pretty difficult to do. But the only way to do it is to order another chip and then destroy it. All right, so big file. But we come into this analog. I've also not loaded the layer map, so it's difficult to see what's going on here. But we've got these analog switches here. We've got one switch for 1.8 volts and one switch for 3.3 volts. And the idea is we're going to take that 3.3 volts coming in from Caravel, from the dev kit, remove this resistor, put our own voltage in there. That will get switched on that switch here, and then it will be accessible to our design. Now, that does make it dangerous because our design is going to still be using 1.8 volt standard cells. And so if you just enable the design, it will probably blow it up straight away. So it'll be a self-destructing design. But we do have a way at the moment of marking a design as dangerous. So you won't be able to just easily enable it through the commander. So that's the idea. So the aim for today is to make a little very, very simple digital block, even smaller than this one probably, connect it up to the 3.3 volt rail, and then its IOs are going to go through the analog IOs, because those ones don't go through the digital muxing, because the digital muxing is also going to be affected. If we've got like a 1 volt output, then maybe that's not going to be enough to swing the 1.8 volt mux or buffer in the multiplexer side. And the same thing, if we're supplying it with a 1 volt core, and then we've got a 1.8 volt coming in from the outside world, that could also be dangerous. So we're not going to use any digital I/O. So we're going to kind of put the digital block, but inside the analog part of Tiny Tapeout. I'm going to try and do all of that and tape it out today and now that I've finished waffling about what we're going to do it in 45 minutes. So Sam is saying level shifters. That's a potential, that's a possibility. But I thought probably the quickest and most transparent way to do it would just be to use the system that we already have in place, because a level shifter that works with differing voltages on both sides is basically going to be a transmission gate, and that's what we already use on the analog side of the circuit. The way that I'm doing it is faster, but it is also more expensive because you have to pay an extra bit for each pin. So what I'm going to do is start the virtual machine. And I'm going to lean heavily on this design. Let me just have a look at my previous designs. It'll be very similar to this one. This is like a mixed signal design. But instead of powering it from the 1.8, I'll power it from the 3.3. It won't have this stuff, and I'll connect its IOs instead of from the top down to the bottom. And I'll also be probably using info from the 0 to ASIC analog course. So quick plug for the course. Got the analog course now on the 0 to ASIC website. So if you want to learn how to do all of this stuff and have access to the design and get a free tape out included in the ticket price, then check out the analog ticket options. Sam is saying, so the digital supply is also going to be changing. No, the idea is we're going to just ignore that. Because all of that logic is designed to be working with 1.8 volts, and we want to make this design as access to the outside world with the least amount of junk in the way. Like, we don't want this mux that's then going to have to be powered from a different power supply or the wrong power supply. All right, so analog template. Also, if you're getting started with the analog stuff, then this page is your friend. This has got the specs. It's got the templates to get started. It's got a little starting off video here, and it's got the link to the template repository. So I'm going to use that. Adjustable PSU digital design. This is going to be a very simple counter. Okay, I think I'm also going to grab this one to get it locally. Okay, so this is the kind of starting off point. And the first thing I want to do is to get a little digital block. So got a make file here. And then also an open lane directory. Hi, Jürgen. Welcome. And this can be quite a lot smaller. And then, where did I say the source is going to be? Verilog RTL. All right. And then I was doing some preparation for this, which turned into a side quest about simulating. So I've got a little counter here that I'm going to just copy and paste. Not like that though. What's going on? Right, so I've got a clock and a not reset and a count. So the other thing is we're limited with the analog pins. We've only got 6 of them, so got 6 pins here. Probably won't get round to simulation now, but just in case we do. And then this is just counting up. So it's extremely straightforward. Set paste. Okay, thank you. What does it do, set paste? Get ready to paste it in. Let me try it out. I've lost my paste buffer. Okay, in the interest of speed, I won't get distracted. So let's see if there's one other thing I'm probably going to need to do. Pin order. So I'm going to put all of the pins on the bottom. So on the south. So I think that will do. clock n reset count. All right, let's see if this works at all. Hi, Peter. Sam saying sometimes Vim likes to insert extra comments and formatting. It's weird because I've not seen that before. I'm really used to Vim, so okay, that failed immediately. Two errors found by the linter. Okay, top module. So got forgot to update the top module somewhere. There we go. Count. All right. Also failed immediately, did it? Three errors found by lint. Ah, dang. So let's call this counter then. And it's probably also going to fail as well. Count. What shall I call it? Count block. Count macro. All right, that's looking good. So that's starting on the digital side now. So let's move on to the magic side of things. So I'm going to copy mag here. And then this is my, okay, going to need VA power, TTUM, MatVen, adjustable PSU counter. So this is, for analog designs, this is really only used for LVS, just like the top level wiring. So I'm just going to need to do something very similar to instantiate the block, which is called count macro, right? And we've got the clock. The N, the reset N. And then we've got, oh no, but they're not coming from there. They're coming from UA 0, UA 1, and then we've got the counter. So that's count, and that's going to be 5 down to 2. It's not going to need the digital power, only the analog power and V ground. Hi, Abdul Maman. All right, where are we at with open lane? Okay, flow complete. That looks good. And that's the top level. And I don't think we need anything else. There's going to be nothing else in this design. So let's move on then to mag. And I need to remove a bunch of stuff from here because I just copied it straight over. So this design is going to be what am I in at the moment? And I want to be using the 3.3 volt template. Probably I should update these to Tiny Tapeout 10. All right, so then in here, I do make start, and that's made me my mag file. Okay, a couple questions. So Andy's saying, how do you set the size of the digital macro that's generated? So that is done. So normally in Tiny Tapeout, that's all, we know the size of the block for the digital block, and that's just the size that it is. But for what we're doing here, we're controlling the open lane config file ourselves. And I'm saying it's a floor planning, sizing is absolute, and then I give it the absolute numbers. So I'm saying it's 50 microns by 50 microns. One reason I'm making it so small is because this, I'm in a stretch goal will be to see if we can do like an analog simulation. And then the smaller the design, the less standard cells, the quicker things tend to simulate. And then Dave is saying, must have missed it. What's the function of this project? So we got asked basically, can I make a digital design where I can like turn down the supply voltage and see what happens as I turn down the voltage? And that's not something you can easily do, because if you turn down V core, that's going to turn down the voltage to all the multiplexer infrastructure as well. So instead, we're like pretending that we're making a digital design, but then we're fitting it inside the analog support framework. So I'm making a custom small design, this little 50 micron on a side design. And I'm just now made the mag file. So now Make Magic should load this up. And I've got along the top, I've got all my digital IOs. Now, if I'm being good, I probably need to tie all the outputs to ground. But for now, I'm going to ignore that. And then here on the bottom, we've got our analog IOs. And so what I've got to do now is drop that digital block in here. So I can never remember how to do that. So over to here, insert the digital block into your design. All right, so start magic with an empty design. I think I also need to because at the moment I don't have anything in GDS, but I can make update files. Ooh. Open name count runs count results final GDS. Need to update this. Count macro.gds. What's happening? Oh, it's because that's probably going to be count macro as well, right? This is all happening because I didn't name my file very cleverly. Okay, well, I got my GDS file at least. Node left. Oh, and I can make a... Okay, now I've got my gate level net list as well, which I don't think we'll be needing today. But now I should be able to come back here. GDS read only true, and then GDS read. GDS read only true. GDS read, GDS count macro. Where's the magic gone? There we go. So we can now see this file that was created. So that's the little counter. And as expected, we've got the 6 pins on the bottom. So they're ready to be connected up. One thing I didn't do was think about the order, because I could have made that match probably better. But I think we'll just go as we're going, because we've only got 20 minutes left. And we're surely going to run into some weird problem. And then write or force, and then my project's name. Write or force count macro dot mag. Or just count macro. Quit. Yes, I want to exit. So now I should have, oops, here I've got count macro.mag. So now I can do make magic, and then should be able to place an instance of the macro. There we go. Siddharth is saying, Are the live streams recorded and uploaded? Yeah, they just record. They go onto YouTube and they'll just stay on YouTube. And Max is saying yes, I could do a make clean and something to rebuild. Yeah, that's what I'm basically. I'm rushing here because I know it's quite a lot to fit in, but I want to get it all done in one go. But we're doing well. We're doing well. So let me save this. Auto write. So I think what I'm going to do is just connect these up in order, and then that the LVS will surely fail because they'll be in the wrong order. But then I'll just adjust what pin is which. And the other thing I need to do is connect the power. So that is ground. So there's a cool wire tool. So I've also, unless I use magic like regularly, I always forget the wiring tool. Spacebar, left click and the wire starts. Right click end. And then is it shift left click to go up and shift right click to go down? So click on here. We're on metal 4. I can't use metal 5, so I need to shift right click to go down. And end the wire there. And then these are probably going to be metal 4. Let me turn on the crosshairs. What's that? Metal 4, yeah, but what's it connected to? That's power. Whoops. Okay, yeah, but that's difficult to select that. Metal 4, yeah, but which is it? Okay, that's ground then. So this one is paint met 4. Ground here. All right. So that's got to go up here and then shift right click to go down to metal 3 and then connect. Okay. So that will do at the minimum. And if we've got time, I can come back and make some more connections here to get a better, stronger connection. And then this one is what? VD power, and that is VA power. So this one is going to come along. So if I go up a bit higher, I can go all the way across and then just come straight down. There you go, V power and ground. All right. And then we're going to do the same thing here. So metal 2. So these are on metal 4, so they need to shift, right click, down to metal 3, down to metal 2, and that should join there. There we go. Then you can see it highlighting all the traces it's connected to. Down to metal 2. Now I've just realized I've not been paying attention to the DRCs, and there's 4 DRCs. So where are the DRCs? Metal 3 overlap a via in one direction. Same place. Same place. Same place. So raise via 3. Whoops, what was that? I just erased all vias. Undo's not working. There, is that? Please tell me. I think I just erased all metal 3 vias in the whole design, and undo's not working. Oh, there they are. So I'm saying, does there need to be some extra M3 on the other side of the via? I don't know. It'd be great to fix this easily. Paint Met 3. Hey, Sam. Sam wins the prize. Thanks, Sam. So now I can see I've got DRC 0 here. So I think we might be good to go on this then. Let's just check the order of our pens here. Still 10 minutes to go. So what is that? Count 0. Count 1, 3, 2, and 3. And then this is clock and reset. So clock is actually clock is there, reset is 0, and then count is 5, 4, 3, 2. Which was this though? That was count 0. So how does Verilog work for this? That's going to be UA5 is going to be, I think that's the wrong way around, isn't it? So does this need to be 2 up to 5? All right, let's try it. So then I should be able to do, we've got a bunch of makefile rules here. I should be able to do a make LVS. Okay, that's not worked because it's not picked up the PVK somehow. Oh, this is missing the magic RC file. That's funny. I thought that had been fixed. And Sylvan's saying I can't do that. Thank you, Sylvan. So I have to do in the curlies, in these brackets. That might be what that is. Let's try again. Error in Verilog file. Oh, something's gone wrong there. No file. R2R DAC control. Did I forget to change the name on this? Or is it something I haven't updated in here? Yes. Okay, so this is... we got that. That's called count macro. And there's no spice files because this isn't a... let me just check that. Verilog GL. Yes. Okay, so LVS run that time, but it's got a failed. Match is 0 and port is 0. UA. So it's getting confused about how the power is connected. VA power. And then UA as well. What are those called in the... they're called V power and V ground. Okay. Oh no, wrong way. UA pins, only 6 are usable. Yeah. But I'm only using 6, Sylvan, so that should be fine. Wrong UA pins. Oh, I think leftmost 6, right. I thought I'd used... yeah, because they start from the right. Oh, shit. Damn. All right. Shouldn't be too hard to fix this. In a hacky way. So Watching that DRC this time. A little bit tight for random hand routing. Okay, this. We're going to balance the signals by doing a little meander there. So it's equal length for optimum skew. All right, so fix the power and the UI, the UA pins. So let's try that again. Still failed. UA 0. Okay, did I not connect it properly? Looks all right. UA 0 goes to reset. What have I done wrong? Yeah, UA 1 goes to clock. I can't see it. It's funny, it's got... Let's see if we can push this anyway. Does anyone know how to set the design as dangerous? So that it can't be selected. We're just running out of time here. So what's this one? Count 3. And do I leave these? These are the wrong ones, aren't they? 6. These aren't the analog pins. It should be here. Yeah, Sam, you got it. Okay, so but that should work, and then I do need a docs readme. I'll come back to this. Danger. Self-destructing design. Remove. Which one was it? It was. Do I still have KiCad open? No. Analog supply resistor before enabling, or you will fry the digital design. Connector variable PSU to the disconnected analog supply and see what happens. Did you set analog pins? Didn't see. Not sure what you mean there, Sylvan. Like in the info, or this is how it's connected up. Are these the wrong way round? See what the LVS does now. Mismatch on those. So it looked like it was right this way around in the info.yaml. Okay, that is close. There's still something wrong there. In the info.yaml, analog pins 6. So that should be good. Let's see what happened on the repo. Probably I need to also enable GitHub Actions for the pages. Actions. Commit. GDS failed. Oh yeah, I need to actually make the GDS. So here, that's another makefile rule. That is make update GDS. But yeah, something is not quite right with this, because all of these should have the RC file. Right. Yep. So I think we're nearly there. I'm going to have to go in a minute, unfortunately. So I can come back to this later. But I think we're just be nice if that had if I was able to resolve this LVS issue. So Something to do with UA0. And this is the extracted netlist. So we can have a look at this. And that's the... Oh, it's got an enable in there. That's interesting. Oh, no, that's the whole thing, isn't it? Okay, yeah, I'm just talking about this one. Count macro. 154320 ground A power count macro. I'm not seeing it. And Sylvan's throwing cold water on this whole party anyway. The analog switches will stop working before your logic does because the VT of the 3.3 volt rated transistor is higher than the 1.8 volt one. Do the transmission gates, the 3.3 volt transmission gate, then get supplied by the 3.3 volts then? Yeah, I guess they must do. So as that voltage is lowered, that's gonna, yeah. Okay, this is a bit of a oversight then. So Sam was right at the beginning to do level conversion and then use the digital I/O. So maybe that's we can come back to that next time. Then I can try to resolve this LVS. Look at level conversion, and then we use the digital I/O instead. So I think I'd call it there. 6:10 for overrunning. So let me just wrap up with the usual comments. Thanks everyone for joining. Cool to have you here. Good to keep on going with this experiment. Next week, same time, same place, 5 p.m. European time. And yeah, leave a comment, subscribe to the channel, sign up to the mailing list, all that good stuff. See you around in the Discord. Hopefully join the community. And I hope to see your design on Tiny Tapeout 10. And thanks very much for joining. Take care. Have a good week.